Welcome back to this character creation tutorial. In this tutorial, we will look at several pitfalls when using 3D characters in Unity. To show you those issues, I re-imported one of the characters that we've been working on in previous tutorials. I simply went back to DAZ Studio, added the vest to the character, decimated everything, and re-exported to Unity. You can see the character here on the right side. And zooming in a little bit, you can see that the inside of the vest here is not being rendered properly. From the outside, the vest looks fine, but on the inside, there is no geometry being rendered. That is normal, because geometry is usually just being rendered from one side. There's two possible solutions. Firstly, we could add additional geometry in here that's looking towards the inside of the character. That would be rendered whenever we see the vest from the inside. However, since we imported this vest from DAZ Studio, we don't necessarily want to add extra geometry and make our workflow much more complex. The second solution is we can make changes to the shader that is rendering the vest. Let's have a look at the vest. You can see here we have different materials, each one being rendered via the standard shader. Now, there's a lot of other shaders here. Instead of choosing any of these, we will simply make some changes to the standard shader to create our own shader that actually renders both sides. In order to do that, we will have to go to Unity's website to download the shader files that come with all these shaders, because Unity does not by default supply us with these shader files. So let's head over to the Unity website, to store.unity.com. Let's scroll down to the bottom, and depending on what kind of Unity version you're using, you're either going to older versions or latest release. And there you can find a drop-down for built-in shaders under additional downloads. Once you download this file, you can unzip it and you will find a list of shaders. Simply go in here, click on Default Resources Extra, and you have a long list of shaders that usually come with Unity by default. At the very bottom, you see the standard shader and the standard specular shader. And for this tutorial, we will simply copy and paste the standard shader over in our Unity project. Before we make any changes, we simply duplicate the shader by using Ctrl D and renaming it to standard double-sided. Now let's open up the shader in our editor of choice. For me, this is Visual Studio. You might be using MonoDevelop. And at the very top, let's change the name of the shader to standard double-sided. Now we have to make two more changes. We're scrolling down to the subshader, and in the section for forward rendering, we simply put in call off right here before CG program. And we're doing the same further down in the section for deferred rendering. Again, we're writing call off right before CG program. Now let's save the shader. And let's see what our shader does. Let's go to the vest. And when we look at the different shaders, we now have our standard double-sided shader available. It's selected for all of our materials. Maybe our buttons don't necessarily need double-sided rendering, so let's keep them with the old shader. And already you can see the inside of the vest is being rendered properly. Okay. Now, up here with our t-shirt, we probably have a very similar problem, even though it's not as pronounced, but you can see the edge here is not being rendered properly. Let's change the shader to standard double-sided. And already, that makes a difference here. You'll probably notice that whenever you start animating your characters, those issues will become more obvious. So it's best for some of the clothing items to simply use a double-sided shader. Now, having a shader around like this is really handy, because whenever you have clothing items such as shirts, or dresses, or jackets, you can simply use those shaders selectively. Alright, let's go to the next issue. For that, let's remove the jacket for now. So you can see this arm is kind of hanging down a little bit. I animated the character to move its arm. And here you can already see some skin coming through. That is a very common issue with any type of character. Whenever you have several layers of clothing or several layers of meshes on top of each other, there's a good chance that when you animate the character and move it around, that skin will be showing through. Or, in some other cases, if we have the vest on top, the t-shirt might poke through the vest. There are several solutions to this problem. We could simply remove the geometry underneath the shirt and make sure no skin is showing through. That would require us to export the character to an external 3D modeler, remove the geometry, and import it back into Unity. Alternatively, there are several tools on the Unity Asset Store that could do that job for us. Unfortunately, that is quite time-consuming, and it will also interfere with our blend shapes. For example, our youth blend shape will change the size of the whole character. If some of the geometry is missing, the blend shape will not work, and it will most likely crash Unity. One other option is to work with the textures of the character. If we can make the texture underneath the shirt transparent, no skin will be shining through. How do we do that? Well, we need to look at our arms texture and our torso texture, and you can see I already prepared some other textures here, but let's get there step by step. Let's duplicate the arms texture to get started with Ctrl D. And let's open that texture. This is our texture in GIMP. It has 3 channels: red, green, and blue. It does not have an alpha channel yet. Let's change that by going to Layer, Transparency, and add Alpha Channel. Our alpha channel contains information about the texture's transparency. Anything that is white in this channel is opaque, and anything that is black is transparent. Our goal now is to hide part of the skin here and here and make it transparent. However, we don't want to destroy our actual texture. We rather just want to tell the image that we want these parts of the image to be hidden and transparent. In order to do that, we need to make changes to our alpha channel. There's a few ways to do this, and I will show you how to use layer masks. Let's use our fuzzy select tool. Click on the white background. Right-click, select, and invert our selection so that only our skin, so both arms, are selected. Now let's go to Layer, Mask, Add Layer Mask. Let's add a layer mask based on our selection. Now you can already see that some parts of the image are transparent, and something changed to our alpha channel. This is what our layer mask just did. Now we want to make changes to this layer mask to also hide these parts of the image. Let's go to Layer, Mask, and Show Layer Mask. And again, anything that is white is being shown, anything that is black is transparent. Now we can start painting on this layer mask here and make changes so that we can hide parts of our arms. Let's use our rectangle select tool. Let's select parts of the upper arm and use the bucket fill tool with black color selected and color this part black. Same for the arm down here. And let's color this part black as well. Now I'm just guessing how much we need to hide here, and we can adjust these things later when we actually look at what it looks like in Unity. For now, we go back up to Layer, Mask, and we apply this layer mask and actually use it as our alpha channel. The end result is this kind of texture where our upper arms are hidden. Now remember, we don't want to destroy our actual image. And I can show you that it is in fact still there. If we were to go to Layer, Mask, and add another layer mask, which transfers our layer's alpha channel, and then remove this layer mask, our image is still here, just to show you that we actually preserve the actual image and can always revert what we just did. If I revert this now again to the image that we had before, we can use this image here and export it to Unity. So again, we added an alpha channel and then made changes to this alpha channel via a layer mask. We painted straight on the layer mask to tell the image that we want to hide parts of the upper arms. Now that we're done here, we can export the image. We have to export the image as PNG file because PNG files actually contain information about transparency. Can leave all of that as it is and click export. Back in Unity, we now have two files with the same name. When we click on them, we can see which one is which by looking at the file extension here. This one is the PNG file. Over here in the inspector, have a look at the alpha source and make sure it is set to input texture alpha, which means that the texture uses the alpha channel that we just created for its transparency. Now, let's disable the shirt on a character by disabling its game object. And let's select the character, and let's apply our texture to the arms. Simply drag it in the albedo slot. Now change the rendering mode from opaque to fade, and already you can see parts of the texture are now transparent. Okay, now we need to do the same thing for the torso. I've already prepared this texture. The original texture looks like this, and it is a little bit more difficult to know exactly which part of the texture maps onto which body part, but with a little bit of trial and error you should be able to change that texture as well. I ended up with something like this. When we apply this texture, we simply go to Torso, drop the new texture in, and change the rendering to fade. And already you can see there's some parts that are still being shown, and this is where our shirt exposes the skin, and the other parts are transparent. Let's re-enable our shirt, and you can see this looks great, and there's no more skin poking through. If you now animate the character, this problem should not show up anymore. We would now have to do the same probably for the pants, and potentially some other parts of the body. Unfortunately, you might have to change those textures every time you apply a different piece of clothing. So obviously this is still fairly labor intensive and not a perfect solution, but it is the best that I can show you right now. We'll talk about some other solutions in other tutorials when we talk about different types of characters from other tools. Alright, let's tackle a few remaining issues. The first one that you might see when I move around here is that our hair magically disappears. Now that is an issue that I would like to tackle in a later video, just because we will have to try out different hair shaders with different hairstyles and see what kind of settings and shaders work best. So whenever you see this here, obviously this needs to be fixed, but this is a fairly complex topic, so we will tackle it separately. However, when moving further away, we also see some other issue. That is here right in the face. Right between the texture for the face and the torso, you can see a little bit of a white line popping up. The further we get away, the more pronounced this gets. This is fairly common for those type of characters, and it is something that we can fix fairly easily. Now, let's have a look at that texture. Select the face texture here, and we can see, first of all, the texture has a white background, and second of all, Generate Bitmaps here is selected, Bitmaps are a very handy feature that allows us to save performance whenever we are further away from the object that is being textured. So when we actually move away from the character, Unity will automatically create lower resolution versions of the texture and save us resources. Because when we're far away here from that face, we actually don't see the tiny details of a high resolution texture, so bitmaps are actually really nice for automatically having lower resolution textures. Now, when Unity creates those lower resolution textures, in that process sometimes the seam around our original texture will get blurred, and if there is a clear color cut like in our texture here with the white background, that white color will bleed into our seam of the texture. That is something that we can fix fairly easily. First of all, whenever you have a texture, you need to decide, do you actually need bitmaps? So is that texture sometimes displayed further away, or is it always very close to us, probably in a static place? In our case with the character, we most likely expect the character to move around and sometimes be further away and sometimes be closer. So bitmaps will actually be very useful. Now, in order to get rid of that white seam, we could simply make changes to our texture. Let's look at the texture in GIMP. All we theoretically need to change is 1 pixel just around here, around the seam where the face ends. Now, that is quite a bit of work, and we could paint around this, but much easier is something that we could do by selecting the background here with our fuzzy select tool. Simply click on the white. And then let's use our color picker tool, select a skin color that's somewhat representative of the overall facial color, and then simply fill the background with this color by using the bucket fill tool. Now, when Unity samples sort of the difference between the background color and the actual face here, we don't have a sharp contrast anymore, and there will be no more white. Let's export a new texture. Let's use a PNG file for this. And in Unity, we can simply apply this texture to our character's face. Let's drag it into the albedo slot, and when we now move further away from our character, you can see, despite the hair missing, the white line is not as pronounced anymore. This is actually a fairly common problem with the characters from DAZ Studio, just because the background of the face textures is often white or black. You will even notice it much more when the background is black, and you can simply just make changes to the texture itself. For the remainder of this tutorial, I would like to talk about optimization. Now, one thing that you can obviously do is go back to DAZ Studio and create lower detailed versions of your characters. So you could use a decimator, create a more simple version of each character, and then create a LOD group and dynamically switch out the different versions of the character based on the distance to the camera. That's a very common way of optimizing performance in your application, and you don't necessarily need a very detailed version of your character very far back. Other ways to optimize your character is to simply look at the different textures you're using and scaling down those textures for things that don't need a lot of detail. You could look at this character here and simply look at all the different textures we have, for example, the eyelashes. And I believe we already scaled down our texture here of our eyelashes down to 512 by 512, because the original setting usually is 2048 by 2048. Now we could do this, for example, for our eyes, where we simply click override and then select the lower resolution version. Click apply. And we simply need to get a little closer to our character and see what the effect is. But this still seems to be fine. We could even go a little lower. And even that still looks fine. Okay, so you could do this basically for all the different textures you have here, because the character from DAZ Studio applies the same resolution to each of those textures, and for some of those textures that is really way too much, and you're using a lot of memory. You can see down here some of those textures are 5.3 megabyte per texture, so that each of these characters actually takes up a lot of space in your final build, and that's obviously not needed. Okay, what else can we do? Well, as we remember, each of those characters has a fairly complex rig attached to them. We can see the hierarchy here, and that is actually a lot of game objects for each of those characters just based on their rig. Each bone is represented by one game object. Each of these game objects has a transform. Now this is obviously really helpful if we want to attach items to certain bones, so that we can simply create a child of a relevant bone, for example the left hand here, and we could have an item such as a gun or some other item move around with the hand. Let's go to our FBX file for this character, and let's have a look at the inspector over here under rig. We have optimize game object as an option here. Let's tick this. This option here will simply collapse our whole hierarchy and get rid of all those extra game objects that we might not necessarily need. Now, let's say we still want to attach something to the left hand. We simply can select that transform here, and we have to go all the way down in the hierarchy to select our hand. This will actually take quite a while here because we have lots of bones. And left collar, getting closer. Forearm, there's our hand. Let's select our hand, and let's click apply. Now what Unity does is it basically gets rid of all those extra transforms and simply exposes our hand. Now we can still add an object to that hand so that our character can easily carry it around, but we're getting rid of all those transforms. That really helps a lot for performance, because whenever our character moves around, Unity would otherwise still have to update all of those transforms, even though they don't really do anything apart from just representing our bones. Now obviously you can do this for various bones here. You can expose the head, the arms, and anything else that you want to attach certain items to that you want to move around with the character. So this option is really important, and this is an absolute necessity to optimize our game objects in this way, because if you have several characters in your scene, you easily have several hundred, sometimes thousands of game objects that are simply moving around for no particular reason. So those are some simple steps through which you can increase the performance of your game, and those are not even very specific to DAZ Studio characters. You can apply those kind of things to most characters, and performance of your game will improve. This is the end of this tutorial, and if you have any comments, please leave them under the video. Thanks for watching.